Hello guys, so today we are going to discuss the GFG POTD problem expressed as the sum of power of natural numbers. Okay, so as you can see the problem is clear from its title only. We need to express the given number as the sum of power of natural numbers, right? So let's read the question. The question states clearly that we are given two number and an x. Find the total number of a's. N can be expressed as the sum of x the power of unique natural numbers. So we need to express the natural numbers which are less than n, because if we express any natural number which is greater than n, then obviously it can't be represented as the sum, right? So we need to take only less natural numbers and express them as the power x the power of unique natural number set. For example, if you see here, in case of n is equal to 10 and x equal to 2, since it is 10, so x2 means we need to raise all the natural number to the power of 2. So here if you see, 10 is equal to 1 square plus 3 square, 9 plus 1, which will equal to 10. So there is only one possibility here. I know you might be wondering that there are several possibilities. Suppose 10 can be equal to 1 square 10 times. That would also result in 10. But the thing is that we need unique natural numbers, not repeating, like 1 and 3, both are separate and unique. For example, there are other methods also, like 2, 2 and 1. 2 square 4, 2 square 4, 4 4 8, 1 9, 1 10. But we need unique numbers. That's why it's having only one possibility here. Also, since the count will be large, we need to take mod of 10 to the power 9 plus 7. This is actually a prime number. So taking a mod of a large prime number always results in non-conflicting values. That's why it is asked to take the mod of a large prime number. So similarly, we have 100 and x raised to power 2. It will result in three unique possibilities as shown here. Okay, so the time complexity we need to solve this problem is n square log n, and space complexity is big O of n. Okay, so guys, we are going to discuss two different solutions here. One will be the time complexity as mentioned here, that is n square log n, and one will be of time complexity n square only. So we are going to optimize this question to make it solvable in time complexity of n square as well. Okay, so let's discuss how we can approach it. So basically it's clear that we need to check all the possibilities, right? We need to check all the combinations which will sum in the given value, right? This is a clear idea. We need to check all these. So what's the best way to do this? The best way is using dynamic programming. Basically dynamic programming states that we need to recurse through all these solution, but we are also memorizing them. So basically on memorizing we are avoiding re-repetition of searching. That's why we can focus on searching all the solution with less time complexity using dynamic programming. So that's the idea we need to use here. Okay, so basically what we are doing is declaring an answer array long, we are taking everything as long. Answer array will contain all the answer till n, till the given n, and at the end we will return our answer n, right? Okay, so let's discuss one function here, that is a power function. Power function basically express the given value in terms of the power. Like this function will calculate x raised to power y. Okay, x and y both are the variables passed as the parameter. Answer, we will initialize answer as 1. This is binary exponentiation technique. What binary exponentiation technique does is it basically calculates the value when y is odd. Means when this power is odd, then only it multiplies the x with the answer, and rest of the time it multiply x, means it squares x rest of the time. Okay, and divides the y by 2. So whenever y becomes odd, then answer is 2x. So this is basically binary exponentiation technique. Okay, so you can find this technique and their details everywhere in the internet. If you see, it will take log n time. Log n means y, or you can say log y time. Okay, so basically here we are using this function to calculate x raised to the power y in short time. Instead of multiplying each time, means instead of big O of y time, we are taking big O of log y time. So we are having number of ways function which will take n and x. We are having two loops. These two loops will result in n square time complexity, and inside these two loops we are using this power, right? We are using this power function which is log n times. So finally it will become the time complexity of n square log n. So what we are basically doing is we are traversing through all the elements because we need values of all these, right? And for each of these element we are checking, means we are applying the dp related thing to calculate the value, current value of the current element, that is j. And if this value is less than what we want, means what is the possibility for n, so we will store that value, we will increment it, and then we can calculate the mod. This mod value is obviously the 10 to the power 9 plus 7, right? So you might be wondering that how I can think of dp in this format, right? Because we are not having any idea. We can also write it in this format, right? J equals to 1, j less than equals to n plus plus j. Then we can write long I is equal to 1, or I equals to 0, I less than equals to n plus plus I. You can also write in this way, right? Because it is dp and we don't know how to approach it in the start. So how to think that this will result in an error or wrong output? How we can think this? So basically we need the logic of this. I am presenting this idea in the video. You can have the channel and you can also subscribe me for such kind of ideas. So basically what is happening here is, if you see in this approach, we are starting from 0 to n, like our all the elements are starting from 0 to n. Suppose our 0th element is updated with this is generally case general this is a general case, right? Suppose our second index, since we are having n iterations, so we our second index is updated with 1, suppose at a moment. Then comes the third index. So suppose by chance the third index is also updated by 1. Now since we are adding, right, we will be adding, so it will add the value of previous index, that is 2. And since 2 is also updated by 1, means if you check internally it will be update 3 as 1 comma 1 comma 1, because 1 might be also updated by 1, right? 1 will be equals to 1 square, 2 will result in 1 comma 1, that is 1 square plus 1 square, and 3, as we can see in this loop, 3 will contain all the previous values. So 1 comma value of 2 is double 1, so 1 comma 1 comma 1, 3 ones will be there. And since this is a repetition and we need the unique thing, so this approach means this loop will not work in this dp, right? This is what I want to explain you here, because we need unique things. Now let's see if we change this thing to this one, which we are basically using here, right? Suppose if we change it to this, then what happens? So we will start from back till the first, right? So we will start from 3. Okay, so 3 will have the value of okay, initially the 2 and 1 will be having, suppose, value 0, and 1 will be having value 1. Okay, so we will be starting from 3. 3 will check the value of 2 as 0, value of 1 would also be 0, right? So 3 will check the value of 2 as 0, and it will just contain nothing else, because this subtracted by 1 will contain 2 and 2 will contain 0, so it will only contain the current value, that is 1. Similarly, if it will check the value of 1, that will come out to be 0. that will also result in 1, and this again will result. Okay, so basically these values are 0, so adding this will result in 0, right? 3, sorry, 1 plus value of 2, and value of 2 is 0, so it will result in 1 plus 0, that will be 1. So basically then we will use only a single one for the 3. As in previous case we were using 3 ones, but this time we will use only a single one. So that's the basic thing. It will avoid this. If we start from the end and move towards the first, then it will avoid the repetition of the natural number, which is what we want in this case. Okay, I hope this will become clear to you, and then and adding and taking the mod, we get our answer. Yep. So this is basically log n square log n solution. Now, as I promised, we will discuss a solution that is of n square. So for that we have an idea that we can pre-calculate all the values as given in this function. If you see here, pre-calculate values, we are defining a vector. Now you might be wondering, it will take more time, more space. So basically it will take only n, and n big O of n space, and this will be also big O of n. So total 2 big O of n, 2n. So it will also be big O of n only. And then log n, log x, it will pre-calculate the values for all the integers below n. It will pre-calculate their power, xth power. Okay, so pre-calculate the xth power of all natural number below n. Yeah, you can see they are using the power function only to quickly calculate the values and store them, and then we can avoid this calling of function, and instead of this we can use this value which is pre-calculated in this function, right? Calling this function once and then running the dp loop, that is n square, and this will take big O of n, right? Big O of n log n, and this dp loop will take big O of n square, and since they are not in loop, so our answer would means our major time complexity would be the bigger one, that is n square. Okay, so this solution will result in n square time complexity. I hope you like both the solutions, and I tried both the solutions and they are working perfectly fine. So I hope in this video you will get the knowledge of dp and how you can figure out which type of dp, which type of loops you need to use, when you need to use them, and also you might be able to get the idea of binary exponentiation, time complexity calculation, and all those things. I hope you like the video. Keep liking, sharing, and subscribing it for more such knowledgeable video on competitive programming by Coding Nights. Thank you guys. Let's meet in the next video. Bye.